Hey everybody, welcome back to chemistry. If I can sort of blow up the slide, please. So the question reads as follows. The energies, or E, for the first few states of an unknown element are shown here in arbitrary units. And then you're kind of given a table there. So let me explain the table. You see that there are two rows. The upper row here is a listing of the Bohr orbits. And then what you have is the lower row, and that tells you that the energy that the electron has in each of the Bohr orbits. So this is energy of electron. Okay. And it says a gaseous sample of this element is bombarded by photons of various energies in these same units. Match each photon to the result of its absorption or lack of by an n is equal to 1 electron. Okay, can I minimize this slide? Okay, so this problem is in reference to understanding the energies of electrons when they're in various Bohr orbits. And so let me kind of remind you of what's going on here. And so here we have the nucleus of an atom here. And so here is the first Bohr orbit, which is closest to the nucleus. And we know that when an electron is in the first orbit, it has this energy, negative 2.18 times 10 to the negative 18 joules. Now, if the electron is in the second Bohr orbit, it's going to have a higher energy. So that's negative 5.45 times 10 to the negative 19 joules, and so on. So as you go out in orbits, the electron gets higher and higher energy until you have the electron that is so far away is completely off the atom. When the electron is completely off the atom is said to be ionized. And if that's the case, when the electron is completely off the atom, its energy is arbitrarily set to 0. So in this problem, what they're saying is this. You're looking at a mysterious element, and what they're doing is they're giving you a scale of the energies of each of the orbits, but they're defining an arbitrary scale. So rather than giving you energy of orbits in joules, they give you energy of orbits in some kind of arbitrary units. So here, the closest orbit to the nucleus here is the first orbit. We're saying in this mysterious atom here that it's going to have an energy of negative 11 units. And so when the electron is in the second orbit, then it has a little bit higher energy, so this is negative 5 units. Third orbit, negative 2 units, and so on. And then when you have the electron completely off the atom, then you have 0 units. And so the problem I'm going to do is I'm going to focus on photon B. And so what they want to know is this. If the energy of photon B absorbed is 9 units, what is the corresponding electron transition that causes a 9-unit absorption of this photon? So actually, this is really kind of easy to figure out. So you might remember when we were talking about Bohr orbits and energies that the absolute value of the change of energy of an electron is going to be equal to the energy of the photon. So we know something already with this problem. We know that if the energy of the photon B is 9 units, then the change of energy of the electron must be 9 units. So you have to figure out what transition here is going to account for a 9-unit positive change of the energy of the electron. One thing they tell you is that the electron always starts out at the first orbit, n is equal to 1. So you have to figure out what transition it is that gives you 9 units of energy. And I think you can sort of see here, if you have your electron jumping from the first Bohr orbit, which is a negative 11 units, to the third Bohr orbit, which is negative 2 units, that energy change is going to be 9 units. And so I think you can see that there. So you might remember it's final energy minus initial energy for the change of energy of the electron. So its final energy is going to be negative 2 units minus the initial energy, which is negative 11 units. And so you have negative 2 units plus 11 units. And so this is equal to 9 units. So yes, when you have an electron go from here, n equals to 1 to n is equal to 3, that accounts for a 9-unit absorption of photons. So it's going to be n is equal to 1 goes to n is equal to 3. Okay, we'll do one more. How about photon A? Which electronic transition would account for a photon absorbing 11 units of energy. And I think what you can sort of see here is that here it will take 11 units of energy to get the electron off the first orbit all the way out of the atom so that the atom is completely ionized into a positive charge. So here for this transition, where the photon is 11 units of energy, that will cause the electron to transition from here, n is equal to 1, to n is equal to infinity. In other words, the electron is completely off the atom. So the answer here, I think, is going to be n is equal to 1 or to n is equal to infinity. If that answer is not available, then it may be something like causes ionization. And I'm going to let you figure out C and D on your own. Okay, thank you for listening. We'll see you next time.